heat calculations. Ready? So first you should have these notes. Let's go over all the reference tables you're going to be using, so be sure to have your reference tables out. So table D. Now we're not going to use all of table D, but we're going to use quite a bit. So paying attention to, we're going to be using this and this and this for sure. So let's look. So what units are we actually going to be using? Mass, we need grams. Temperature, now we can use it in degrees Celsius or in Kelvin. It doesn't matter for the heat formulas that we're going to actually be using. We've talked about heat before. Heat is moving energy, so it's thermal energy that is moving, and it's moving between two objects that are in contact. Now, understand that the air is in contact with my hand, so that's in contact. But anyway, it is moving from warm object to cold object. Okay, so from warmer to colder until their temperatures are the same. So the heat will continue to move from warmer to colder. Okay, and typically we're going to see heat in this unit, which is joules, but it could be in kilojoules, it could be calories, and it could be kilocalories. We're also going to need table T. So we have 3 specific heat formulas. And then this is to do temperature conversions, which we don't necessarily have to do because we could use for this delta T, we could use either Celsius or Kelvin. Now it doesn't matter because we're just finding the difference. So we're subtracting temperatures. So in Celsius and in Kelvin, the answer we get is going to be the same. Because, for example, the boiling point of water is 100 in Celsius and the freezing point is 0. In Kelvin, the boiling point of water is 373 and the freezing point is 273. When we subtract in both situations, we're going to get 100. So it doesn't matter as long as they're both either in Celsius or both either in Kelvin, because we're going to get the same answer when we subtract. We also need table B because you do not have to memorize the heat of fusion for water, the heat of vaporization, or the specific heat. It's in the reference table. Now, if they ask you about a substance that is not water, they have to give you these values, or could give you everything else and you calculate it. All right, so what about calculations? Let's go through some important parts to doing the calculations. So first of all, when there is no temperature change in a problem, you're going to use one of these 2 formulas that you see here. If in that problem it talks about something going from a solid to a liquid or a liquid to a solid, we use the formula that involves heat of fusion because fusion means melting. And so it's either going to be solid to liquid melting or the reverse, liquid to solid, which is freezing. It's all going to use that heat of fusion formula. If, on the other hand, the question talks about it going from a liquid to a gas or from a gas to a liquid, we're going to use the heat of vaporization formula. So I like to think about it like this. If a gas is involved and it's changing from a liquid to a gas or gas to a liquid, meaning no temperature change is happening, vapor is a gas. Okay. Now, if there is a temperature change, you have to use this formula, which is a little bit longer and includes change in temperature. Why don't we include change in temperature in the other formulas? Because the change would be 0. My answer would be 0 because I'd be multiplying by 0. So I don't want that. So I only use this formula when the temperature is changing. Now, delta T is the change in temperature. How do you find it? You take the temperature that you end with minus the temperature you started with. The order matters. Talk about it. Something else that's in that equation is the specific heat capacity. What is specific heat? It's the amount of heat it takes to raise the temperature of 1 gram of a substance 1 degree Celsius. Now for water, it's listed on table A. For any other substance, it's got to be given to you or it can be calculated with all the other numbers, but you're not expected to memorize any of them. Water's in the reference table, the others you'd have to get. Now, remember how I said that the order of the temperatures mattered? Well, this is why. If you get an answer that's positive, so the heat is positive, that means endothermic energy was absorbed. If you get a negative answer, that's exothermic energy is released, just like in table I, right? So again, if it is endothermic, we should see a positive sign. If it's exothermic, it's going to be a negative sign. Now, these calculations can be applied to heating and cooling curves. What do I mean? Let's look at a couple examples. So if 300 kilojoules is added every minute, how much heat is added while the substance melts at its melting point? So let's kind of go through the answer step by step. Well, first of all, it's melting in section 2. So right here, because this is a solid, this is solid to liquid. Here it's all liquid, liquid to gas, and then here it's all a gas. So during this section right here, right, it is melting. Now, section 2 lasts for 4 minutes, from minute 4 to minute 8. So that's 4 total minutes, right? If 300 kilojoules were added every minute and it took 4 minutes, 300 times 4 is 1200 kilojoules. All right, let's look at another question. How much heat is added as the substance boils at its boiling point? So here it's labeled boiling, right? So this whole line right here. So boiling begins after, so right here, 50 kilojoules have already been added, starts boiling. And then it stops boiling when 100 kilojoules are added. That means we do 100 minus 50, so we get 50 kilojoules. All right, let's look at some examples that do not involve heating curves. Are you ready? Okay, so what is the total amount of heat energy in joules absorbed by 25.0 grams of water when the temperature of the water increases from 24.0 degrees Celsius to 36.0 degrees Celsius? Is the temperature changing? You betcha. Now I know the formula. There we go. What do? Make my list of variables. Okay. Go back to the question. It says, what is the heat? I got the mass. Where am I going to find T? Well, it's water, right? It says it's water from table B. And then for delta T, I need to do ending temperature minus starting temperature, final minus initial. So final minus initial, it's going to give me that delta T. Plug the numbers in to the equation. I get this, and then I just do the math. I get this. Now, sometimes on the question, they'll have the answer in kilojoules. So what you have to remember is that 1 kilojoule is 1,000 joules. So I need to move the decimal 3 places. So those are both possible answers. The only time you need to worry about the kilojoules conversion is if it's a multiple choice question. If it's not, just you write what the calculator gives you. All right, here's the next one. Determine the total amount of heat released by 5.00 grams of water vapor as it condenses at its boiling point. Does the question mention temperature change at all? There's not even a temperature in the question, right? All it says is that it's boiling point. What's the boiling point of water? 100 degrees Celsius. But it doesn't say it went up, it went down, nothing. It just says it's at its boiling point. So I know I don't need the one with delta T. Now, which one do I need? Well, it's boiling and it says vapor. I need this one, right? Make your list of variables, plug in the numbers. Finding the heat, 5 grams of water. Now, where do I find the heat of vaporization? It's not in the question. Table B, because it's water. So I just copy it from table B. Plug the numbers in, multiply. Now, I could just write it like this. If it was a multiple choice question in kilojoules, I could also represent it in kilojoules, or I could represent it in scientific notation. So those are three possible answers. If it's just a question I have to solve, I'm given the first answer, 11,300 joules. I'm not doing anything extra. But if it's a multiple choice question, you may have to look a little. All right, our last example. A 150.0 gram sample of a substance absorbs 765 kilojoules of heat at its boiling point without a change in temperature. Determine the heat of vaporization for the substance. Now it says no temperature change. Delta T formula is out. I see boiling point and it mentions heat of vaporization. It's not a far stretch, right? Write down my list of variables, plug in my numbers. That's what I'm trying to find. Put them into the equation where they belong. Okay, now I could change this into joules like this. I don't necessarily have to, okay, but I did in this case, changed kilojoules into joules. Now I'm going to divide both sides by 150, which will give me the heat of vaporization. Now, if I had not done that, my answer would not be wrong, but instead of being in joules per gram, it would be in kilojoules per gram. It just depends how the question is worded, okay? So it could be also written like this in scientific notation. So those are two possible answers. But in addition, we could just say 5.1 kilojoules per gram as well. So there's lots of possibilities. You may have to kind of just look at what the multiple choice answers are, but if you have to solve it on your own, you don't have to do the extra stuff, okay? I hope that helps.